Hi guys. Hello. Good evening. So today we will be learning permutations and combinations. So this is 11th standard portion. And when you take about permutation and combination, it is very important chapter when it comes to JEE entrance or your VIT entrance or Amrita entrance or any entrance examination for your engineering. So this permutation and combination along with your APGP contains a little amount of higher weightage. Okay. So this is really important when you're dealing with a competitive exam. This is really important. So yes, so just give me a quick hi. So let's start the class immediately. Yes, so let's start the class as soon as you give me a quick hi. So yeah. Okay, so now we'll be starting with what is a permutation. So before going into definitions of what is a permutation, why do you what is let's talk about why do you have to learn permutation. So basically, for example, you're taking a deck of cards, okay, and you need a probability of getting king or something. So in that, permutation also involves. So basically I'm just telling a less like a very minute example, but there are different examples where permutation plays a major role. For example, even selecting, suppose you're having a few balls or a few flowers, in that you have to select any one thing. So that for that also your permutation plays a major role. Okay, so basically permutation means permutation and combinations are involved only in the cases where selection plays a major role. So in this case, permutation and combination is very important. So yes, so what is a permutation? Permutation is nothing but arrangement of objects in definite order. So you are having a particular order, right? The arrangement of it. What is the arrangement? Arrangement of objects, basically. Arrangement of objects in definite order is nothing but the permutation. So you may ask me, if it is the order is the order fixed or something? No, actually the order is not fixed. The order is defined according to the problem, but arrangement of that in the order given is called your permutations. Okay, so that is your permutation. I hope you are clear with it, right? So now let's talk about, see, now when you are talking about arrangement, whether the arrangement can be a linear arrangement or it can be something, right? So members or elements of the sets are arranged here in a sequence or a linear order. So generally, now we are talking about the arrangement. How will it be? Whether it will be in a linear order or different types of order, right? In that case, what we can do is, generally the arrangement is in a sequence. You will have a sequence behind the arrangement and or a linear order behind the arrangement. So in this case only you say it is a permutation. So this is basically how will the arrangement be. So how will the arrangement be? So generally your arrangements can be anything. Now let's talk about the members. What all the members? So generally it is an object. It can be any things, basically a car or flowers or ball or box, or it can be even numbers at times. So basically arrangement of these things are your permutation. So now let's talk about basic principle of counting. So what is your basic principle of counting? Suppose if there are m ways to do one thing, okay, if there are m ways to do one thing and n ways to do another thing. So generally you're taking two things. Okay, you're having m ways to do one thing and n ways to do another thing. In this case, what happens, how do you define the total ways? So there are m into n ways to do things. So basically what is happening is you can do things in m cross m ways. For example, this will be slightly confusing, so now let me explain. See, you are having how many so look at the example here. So you're having a blue color flower, and you're having a yellow color flower, you're having a pink color flower, and you're having a red color flower. Okay, and here you're having a red color ball, blue color ball, red color ball, yellow color ball, and green color ball. So basically, how many objects are there in this side? This side. How many objects are there this side? So basically, you are having 3 objects this side. And basically, how many objects are you having this side? So here you are having 4 objects. So the arrangement of the balls can be done in 3 ways. Same way, the arrangement of the flowers can be done in 4 ways. Okay. Now what happens? So here, how many ways in total you can do? So total number of ways of doing things or arranging things. So basically, my question for this figure will be, I'm asking you to get one ball and 1 flower. If I'm asking you like that, so you can one ball is selecting from the 3 balls. So basically, in total, you're having 3 balls and 1 flower you're selecting from the 4 flowers. So basically, 4 ways of selecting flowers are there. So in total, how do you choose 1 ball and 1 flower? You're choosing 1 ball and 1 flower in 12 different ways. So there are 12 ways to choose 1 ball and 1 flower. So let me explain you with the diagram. So basically, your total ways is 3 into 4, which is nothing but 12. So 12 ways are there. In total, there are how many ways? 12 ways are there. Okay. Now, let me show you. So now here, what am I taking? First, I'm taking the red ball. Okay. So I'm keeping the ball as this side. I'm keeping it like this. Okay. So you're having the red ball. You're taking 1 red ball and 1 blue flower. So 1 blue flower. Okay. This is first arrangement. Now, same color red ball, you can take with which flower? You can take with yellow flower, right? So you're using what flower? Yellow flower. This is not yellow, but yeah, just assume this is yellow. Okay. Now, same way, the red ball, you're choosing the red ball, and what else is there? Pink color flower is there. So what flower you are having? Pink color flower you are having. Same way, what is that? Red ball, and what last flower? What are you having? Last flower is red flower. So red flower is nothing but you are having red flower. So basically, 1 red ball you can pair it with basically I just want 1 ball and 1 flower. So first, what am I taking? It can be red ball also, it can be blue ball also. If I'm concentrating on the red ball, 1 red ball, I can pair it with 4 flowers. Same way, now what is my next color? My next color is yellow. Same way, yellow ball, what can you do? Yellow ball is paired with all the 3, okay? So your yellow ball is paired with all the 4 different colors. Same way, now let's talk about the green ball, the last green ball, which is nothing but, so the last green ball is basically, so this is your last green ball. How can you do it? So basically, this will be, so your last green ball is paired with again all kind of. So if I'm asking you 1 flower one ball. You can pair the red ball with blue ball. You can pair the blue ball. You can pair the yellow ball with blue ball. You can pair the green ball with blue ball. So let's see how many how many permutations are there. How many ways can you do it? So I'm using this black color for. So you're having one way. So basically, how many ways are there? You're having 1, 2, 3, 4. And 5, 6, 7, 8, 9, 10, 11, 12. So in total, so if you're having totally you're having 3 ways to take a ball and 4 ways to take the flower ball. So in total, I told you, you have 12 ways. So there are 12 ways of getting things. So this is the I'm just erasing this because there won't be any confusion. Okay. So this is your first principle. So if you're having m ways to do one and n ways to do other, so what are the ways to do both? Okay. Now here, what is the second principle? So this is the first principle. Now let's talk about the second principle. So second principle, how shall we do it? So if there are m ways to do one thing, same way you're having m ways to do what? To do one thing, okay? And n ways to do another thing, okay? So same way you're having m ways to do one thing, n ways to do another thing. Now, both cannot be done at the same time. So, you cannot do both at the same time. Either you can do one thing at one time. So, in the previous case, either you have to pick the ball at once or the flower at once. Okay. So, you cannot pick both the things. So, there in that case, what you should do, you basically have to add the both the number of ways. Okay. So basically your m plus n will be, basically you have to add it. Okay. That is what we have to do. Now what happens? So here, same example, I cannot choose both the things, right? So here I cannot choose both the things. One is, here I have 3 balls and here I have 4 flowers. If I'm asking you to choose one thing at a time, so what can you do? You have only 7 ways. In total, how much is that? Totally 7. Out of the 7, for example, if I ask you to put all these things inside a box, okay? If I'm asking you to put inside a box and pick one thing, so how can it be done? So basically, you'll be choosing one at a time. When you're choosing one at a time, out of the 7 only, you will be choosing. That is what total number of ways in which you can get is 7. So here, basically, this point is very important. Both cannot be done at same time. So both the things cannot be done at the same time. Okay. In this case, it is addition. Suppose if both the things can be done simultaneously, in that case, what you can say, that is multiplication. So this, let me draw and show you. So basically what will happen? So I'm having a red ball. So for example, this is your red ball, then your yellow ball. So then your yellow ball, then your green ball. So then your green ball, then your all the flowers. It will be first will be your, it is not necessary first should be a blue. So I am just writing first is your blue. Then comes our yellow. And then comes our pink. Okay. Then comes our red. So in this case, what will happen? So basically, I have to choose, and my question is, choose one object, okay, at a time. So out of this, if I choose red first I'll be choosing just red, okay. Next, if after choosing red, next, if I ask you to, like, if I want to choose some other thing, so first if I choose red, 1 happened, okay, 1. Then if I'm asking you to choose some other thing, some other color, so it will be again I'm asking you to choose red flower. So it will be 2. Okay, basically 2 times, second time, there are second way. Okay, now if I'm asking you to choose blue color flower, what will happen? So I'm just choosing the blue color flower again from the lot of 7. So basically when you're choosing one at a time, you'll be having 7 ways to choose it. Either you can choose green flower, yellow flower, blue flower, red flower, pink flower, or green ball, green ball, red ball, or yellow ball. Like this only it will be happening. So your total ways of picking. So your total ways to choose one of the things. To choose one of things is basically what? So when you choose only one of the things, what will happen? So basically it is 3 plus 4, that will be equal to 7. So you'll be choosing just 7. You'll be having 7 ways to choose just one of the things. So whereas here you had 12 ways. Now, did you understand the difference between the first principle and second principle? The major difference between the first principle and second principle is, in second principle, you'll be choosing one at a time. But in first principle, you can choose as many as things as you can. Okay, that is the major difference. Now let's quickly see the types of permutations. So basically when you look at the permutation, so you are having into 3 different categories. Okay, so one is you can have n different objects. So permutation with n different objects when repetition is not allowed. So it can be first, for example, if I tell you, it can be what is this? Green ball. It can be red ball, it can be pink ball, but it cannot be 2 pink balls. There cannot be 2 pink balls because you're having, it is n different objects. What does that mean? Basically, the repetition is not allowed. That is what is given here. Okay, so same kind of objects is neglected. Different kinds of objects are in the first category. Now let's go to the second category. When you're seeing the second category, it is repetition. Repetition is allowed. What does that mean? See here I gave you an example. This is not true for the first point, but whereas the second point, what will happen? Second point, your repetition is allowed. What does that mean? It means that you can have the objects, you can have same kinds of objects. Same kinds of objects, not necessary everything should be same, but that can be, that is allowed. But in the first condition, it is not allowed. Okay, that is the main difference. So here, when you talk, so here it is 1 pink ball is there. So again, you can have 2 pink balls. Again, you can have 1 red ball and you can have a green ball. So this is allowed here. Okay, because your repetition is allowed. But whereas here, it is not allowed. That's why I have put a cross mark. Okay, now permutation when objects are not distinct. Permutation of multi sets. So here your objects itself is not distinct, which means it is somewhat similar to the previous thing. So your objects can be similar. That is what they are saying. Your second point and third point are almost similar, but mostly we won't be dealing with the third points. Mostly we won't be dealing with the third points. In our syllabus, mostly it is dealt with only the n different objects or the repetition is the only these 2 categories are mainly involved in our syllabus. So yes, now let's talk about the permutation formula. So again, I have written the definition of it. So a choice of r things from set of n things. So basically here, what is my r? R is the choice, number of things we are taking, okay, from the total. Basically, this is your total, means here the total number of things are n. So, the choice which we are making or the number of things which we are getting from the total is our R. So, that is without replacement. Again, you're not replacing it. You're taking it, that's it. You're not replacing it. So in this way, how do you write it? N NPR is equal to n factorial by n minus r factorial. So here, as I already told you, n is the total number of things, and from that, if you're taking particular thing without replacement, then you say it is n minus r factorial. Are you clear? Are you clear? Yes. Okay, so now let's talk about the combination formula. Okay, so here what is a combination? Till now we have spoken about permutation. Now what is a combination? Combination is choice of r things. Same way, choice of r things from n things without replacement when the order doesn't matter. Here order doesn't matter, but here the order matters. In permutation, your order matters. The way in which you're arranging the object matters. But here your order doesn't matter. What does that mean? Which means the way in which you arrange the object doesn't matter for combination. So basically NCR, how can you write? NCR is nothing but n factorial by r factorial into n minus r factorial. Like this only we will be able to do it. Okay. So like this only we will be able to do. NCR is nothing but n factorial by n minus r factorial into r factorial. So basically you can also write it as NPR divided by r factorial. Why? Because you are having n elements. Okay, you're choosing 3 elements from this. In that 3 also your order can change. You can have it in any order. So that is why it is written as r factorial. Okay, but here whereas you are having n objects, you're just choosing 3. Here the order matters. You just follow one order. That's why it's 1 factorial, which means you're just following just a single order. But in that itself, for example, if I tell you, you're having a red ball, you're having a blue ball, you're having a yellow and black ball. So from the 4, if I choose 2 balls, okay, from the 4 balls, if I choose 2 balls in combination, it can either be blue, let me show. It can either be blue red or red blue. In that itself, you can have different arrangement, right? Because here they told you arrangement doesn't matter. So from 4, I'm picking 2. In that 2 itself, I can have different order. That's why an extra r factorial is given. But when you are talking about permutation, the order in which you're taking is fixed. It matters. Okay, so that is why there r factorial is not there. Now let's do about the number of permutations and combination if n is equal to 12 and r is equal to 2. So basically here it is given my n is equal to 12, r is equal to 2. So what is number of permutations they are asking? So basically NPR is nothing but n factorial by n minus r factorial. Okay, now this is my formula. Okay, now what can be done? So I'm taking 12p2. So 12p2 is basically 12 factorial by 12 minus 2 factorial. Like this it will be there. So when I further do it, so this will be 12 factorial divided by, this is nothing but 10 factorial. Okay, so when I further do it, it is nothing but 12 into 11 into 10 factorial divided by 10 factorial. So now, because what is my factorial? N factorial is nothing but n into n minus 1 into n minus 2. It goes up to 1. That is what. So I can write it as 10 factorial. 10 factorial is again 10, 9, 8, right? So I can cancel these both things. Now what can be done? What is 12 plus 12? It will be 132. My 12PR, which is 12P2 is nothing but 132 is my answer. What is my 12P2? It is 132. Now let's go to the next one. I have to find my NCR also. What is my NCR formula? NCR formula is nothing but this is combination. This is combination. Just now we did about the permutation. So this is permutation and this is combination. So what is combination? This is basically n factorial divided by r factorial into n minus r factorial. So basically what is my n? 12C2. 12C2 is nothing but 12 factorial divided by 2 factorial into 12 minus 2 factorial. Like this it will happen. So when I further do, it is 12 factorial divided by 2 factorial into 10 factorial. Like this it will be there. Now what will happen if I split the 12 factorial? How can I write it? It will be basically 12 into 11 into 10 factorial divided by this 2 factorial I am splitting. It is 2 into 1 into 10 factorial. Now I am cancelling the terms. This and this gets cancelled. This and this. So it becomes 6R. Basically my NC 12C2 is nothing but 6 11s are is nothing but 66. So 66 is my answer. So are you clear? So this is my answer. 66 is my answer. Now similarly, let's see about the other things. So see, in question it's given that in dictionary, if all the permutation of letters of the word, again permutation means the order matters. So it is given that all the permutation of the letters of the word again are arranged in the order. What is the 49th word? That is what they are asking, right? So when I further do it, what will happen? So now let me arrange it. So first let it start with A. So how many letters it can start? Either it can start with A or G or I. Okay, it can start with these many things. So now let's see. So basically it can also start with N also. So now let me start with A. So when I further do, it will be start with letter A. So if I start with letter A, what will it be? So the arranging, how will I arrange? Arranging the other 4 letters. So other 4 letters are what? G-A-I-N. So arranging other, so if I'm starting with A, arranging other 4 letters, what are the other 4 letters? G-A-I-N. So I can arrange that in 4 factorial ways. Either I can put N first, G first, A first. You can have, like generally if you're having 4 letters, 4 objects, arrangement of it can be done in 4 factorial ways. So which is basically what? 24. So first word has what? So basically what can I say? My first, so these are my first 24 words. So if I arrange that, it can have in 24 ways. So it is my first 24 words. Now what about if it starts with G? So if I start with G, so if I'm starting with letter G, how can I do it? So basically you have to arrange the other words. So now it will be arrangement of other words. What are the other words? Basically A. So basically it will be A-A-I-N. So except G, other words you have to arrange. So what will it be? Arrange A, I and N in different ways. So different ways. So basically total arrangement is So if you're having total arrangement, 4 elements are there. So how will it be? It will be 4 factorial ways of getting it. But there are 2 repetitions. Since there are 2 repetitions, it is divided by 2 factorial. Then what will happen? 4 into 3 into 2 factorial by 2 factorial, which is nothing but 12. So totally, if you're starting with G, you can arrange in next, these are my next 12 words. It is my next 12 words. So basically they ask me what is my 49th word. So 24 plus 12 is 36. Now next thing, let's start with, here I'm starting with letter I. So if I start with letter I, what is it? Arrange. So again I have to arrange, except I have to take A, G, G, A, G, A, N. Okay. So what will it be? Arrange A, G and N in how many ways? In different ways. So again, if I'm arranging it in different ways, what can happen? So again, I'm having 4 ways to arrange, divided by how many repetitions are there? 2 repetitions are there. So divided by 2 factorial. So I'll get it as 12. Okay. So this is my next 12 word. Next 12 words. So basically till now 24 plus 12 is 36. 36 plus 12 is 48. So my 48th word should start like 49th word. So till now I have did it with 48th word. So my 49th word definitely should start with N, because first I'm starting with A, it did. So I'm starting with G, it is okay. Then I'm starting with I, that also finished. Till 48 is there. Next word should start with N. So how will it be? So my word is nothing but NAAGI. This is my word. So this is my 49th word. So I hope you're clear with the concept of what is a permutation, what are the types, what is the first principle, second principle, and few examples of it. So let's meet in the next video with the new content. Until then, it's bye from Harismita. Bye bye.